A battery with negligible internal resistance is connected in series with a resistor, like dependent resistor LDR. So here we got the LDR. This is LDR. So LDR is a light dependent resistor, and its resistance changes with the exposure of light, right? And this is a normal resistance R, all right? And now the point here is we need to figure out the light intensity on the LDR is decreased, all right? So they're decreasing the light intensity on the LDR, and how does the readings of the voltmeter change? We need to figure out that, right? So we need to figure out what's the voltmeter reading on P and what's the change in the voltmeter reading on Q, right? P is the voltage across resistance R, which is a fixed resistor, and Q is the voltmeter reading across an LDR, right? So let's first understand how LDR works. So if we draw a graph with the intensity of light on y-axis and resistance on x-axis, so how does the resistance of an LDR changes with the exposure of light? Actually, as the intensity of light increases, the resistance decreases. Okay, the resistance decreases as the intensity of light increases. So the more intensity you have, the lesser will be the the more intensity you have, the lesser will be the resistance, and the lower the intensity you have, the higher will be the resistance, right? So this is the point, and this is the point. So our graph will look like this. So it would be an exponential decay, right? The more high intensity, low resistance, and as you decrease the resistance, the intensity keeps on increasing, right? So that's how the resistance changes for an LDR. Now what we are concerned with are the values for the voltmeter P and voltmeter Q, right? And we need to know the circuit theory for that. So what the point is, where the change is happening, the change is happening over here. The intensity on the LDR decreases, so they are decreasing the intensity on the LDR. All right, so when you decrease the intensity, so for example, if you're here and the resistance is this R1, then you decrease the resistance. Now you're here. Now the resistance is R2, so the resistance will increase. Right, decreasing the intensity will eventually increase the resistance for an LDR. Now we are sure that the resistance will go up for the case of this LDR, right? And this is fixed resistance. Now what will happen with the voltmeter P and voltmeter Q reading, right? So according to Ohm's law, V equals to IR, right? The overall current in the circuit will decrease. Okay, overall current in the circuit will decrease because this is a series circuit and current is flowing, for example, this way. So overall current, for example, the current when the LDR when the intensity was not decreased, the current is I1. And when the intensity increased, the resistance increased. When the intensity decreased, the resistance increased for the case of LDR, and that causes the current in the series circuit to decrease, right? And when the current decreases, the voltmeter reading across P will be decreased. Why? Because again, V equals to IR, right? Now you are having lesser current flowing through the resistance R, this fixed resistance R, so you would be having lesser value for V, the potential drop across the fixed resistor R. So we are sure that the voltage value for fixed resistor R, which is the voltmeter reading P, will be dropped. Okay, so this will decrease. So we are sure that it would be one of the following, from A or B, not C or D. Why? Because C and D are for increasing. Okay. Now we need to choose from A and B which option we should go with. So we'll be able to decide this by deciding what will happen to the voltmeter reading Q. Okay, so voltmeter reading Q, because see, the current decreases for the series circuit, but the resistance increases for this LDR, right? And it decreases exponentially. It's not decreasing linearly. All right, so it's decreasing exponentially, which means resistance would be increased and current will be decreased, right? So according to V equals to IR, current is decreased, resistance is increased. So what will happen overall? Well, the voltage drop across Q will increase or it will decrease. Actually, it will increase. Why? The reason is, there are two reasons. Because we cannot confirm from this equation V equals to IR, but we can confirm by the Kirchhoff's law, because Kirchhoff's voltage law says the overall voltage drop in the circuit will remain equal to the total EMF of the circuit, right? So now you're having a lower voltage drop across this side. Okay, now you're having lower voltage drop across this side. This means you will be having higher voltage drop on this side. Okay, lower voltage drop on this side, so this means the higher voltage drop on this side. So this means the voltmeter value for voltmeter reading on Q will increase. Okay, so option B is the right option for this case.